As we're getting set up, thanks very much, Mackenzie, for the kind introduction, and it's a real pleasure to be here at AWS Startup Day. As Mackenzie mentioned, I'm CTO at Cybersecurity, which is a startup in Mountain View. We protect the world's largest banks, airlines, retailers, insurance companies. What were the primary line of defense for many of the applications that each of us use on a daily basis. And prior to Shape, I led product management for click fraud protection at Google. And click fraud was the primary threat to our business model there, which was at the time more than 99% pay-per-click advertising. So we've seen a great deal of change in the security ecosystem, in the cyber criminal ecosystem over the course of the last couple of decades. And I wanted to share some of those learnings with you guys as you think about how to approach security and defending your applications and your services that you're making available to the external world. Because I think that there are common paths that companies often go through in terms of investing in topics like security, and there are probably some changes that we can observe in how companies are thinking about those as a result of some incidents that have occurred over the last several years. So it's going to give away what the next slide is as we scroll a little bit, so you'll have to excuse that. But to begin with, how many of you value keeping your personal data private? Raise of hands. All right, and how many of you would value being able to use applications that are secure in terms of their application security? All right, so this is a pattern that you see quite commonly when you ask folks how much they value topics like privacy and security. So there was a survey that was conducted a while ago, and one of the things that we saw is that in some cases, people value privacy more than security. In other cases, they value security more than privacy. But in general, when you ask people whether or not they value these sorts of concepts, the answer is yes. Unfortunately, when you observe their behavior, one of the things that you see is that it doesn't necessarily line up with what they say in the surveys themselves. So this was a study that was conducted at MIT where they asked students to give away some of their friends' private information in exchange for some pizza. And it turns out that that's not only a powerful enough incentive to violate your friend's privacy, but it's also a powerful enough incentive to give away some of your own security, as they discovered in the same experiment. And this is something that affects the way that people think about building security and fraud controls into their applications as well, from a technology industry perspective. And no company is really immune to this, except maybe particularly paranoid companies or companies that have had bad experiences before. And I think that one of the best examples of this is the introduction of security as the #1 priority company-wide at Microsoft in 2003. And so this was the Trustworthy Computing Initiative that Bill Gates emailed the entire company about, and it came after Microsoft had had some very severe public incidents with the code Red Worm taking over hundreds of thousands of hosts around the world. And this demonstrates a pattern that many companies fall into, but in particular, startups fall into, because you have a limitation on the amount of resources that are available to be able to invest in any given endeavor. So how many of you, when you embarked on your startup or whatever project it is that you're working on right now, that the immediate first step for you was, I need to hire a chief information security officer? One person, which is pretty great. Maybe you're in the security industry? Yes. So I think that that's very typical in terms of the way that startups have to prioritize their resource allocation. And that process typically looks like this. You want to develop your technology. You want to be able to create that capability that differentiates you from everyone else. And then you want to be able to grow that capability. You want to be able to reach traction in the audience or in the market. And when you do reach a certain amount of traction, when people are using your services at a certain scale, that's when you also create enough value that you attract the attention of folks that want to attack you. There's a reason then to be able to go and attack that service, extract the value that's being hidden or being secured within that service, and that's often when companies experience some sort of security incident. As a result of that incident, companies generally take action, and that action can take various forms. It usually takes the form of new defenses being introduced, new security technologies being purchased, new security mechanisms being created, processes being altered, a new position being created in some cases, a chief information security officer for the first time in many organizations. For more mature organizations, the process often looks like asking themselves, what did we do wrong based on our old processes, and changing those, including sometimes firing their current CISO and bringing in a new CISO. And so if you look throughout the industry, you see that there's kind of a musical chairs game of chief information security officers that often gets played as a result of the desire to say that we're going to make change and demonstrate that simply by changing some of the folks that are responsible for these positions. But there's another layer to this, which is it even responsible in the first place to approach security this way? This was an article that came out in the Chronicle a while ago, and it was discussing the idea of producing functionality that's going to be used by a large number of people that has vulnerabilities introduced inadvertently. Nobody intentionally builds in vulnerabilities, but if you don't put enough attention into protecting your application against potential vulnerabilities, are you actually being irresponsible if people can be harmed as a result of that? Interesting question. So I want to talk a little bit about the term cybersecurity. And it's been kind of amusing to me that cyber, even without the security, has become synonymous with cybersecurity in certain circles, because 10 years ago, if you were an information security professional, you didn't call it cybersecurity. In fact, when I started discussing cybersecurity with some of my InfoSec colleagues from Google and with other firms, they sort of looked at me like I had two heads, because that's not what you call it if you're really someone that is steeped in this area. But what I discovered was that this is actually the term of art that has arisen in non-technical circles. So when it comes to folks that are approaching it from a government perspective, or approaching it from a political science perspective, or from a business perspective, it's actually called cybersecurity. So when I was in college and studied computer science, or later when I studied management, in neither of those two contexts were there any cybersecurity courses that were mandatory or usually even available. And now you see cybersecurity courses offered in leading business schools. You see security being part of the standard curriculum of computer science programs. And I think that that's a very positive thing. But that's not the way that it was 10, 20 years ago. And so the reason that I've put cyber in quotation marks here is because this is also a way of thinking about how terms become popularized throughout society. First of all, they start off being called so-called something. So it was originally called so-called cybersecurity, as journalists introduced this term to the audience. And then they started to put it in quotation marks, cybersecurity. And by the way, if you ever want to make something trivialized and seem unimportant, just put it in quotation marks. So, putting someone's title as co-founder in quotation marks, you can see the reaction that that'll produce. And that's exactly what happened when cybersecurity was treated with this kind of diminutive. But that's no longer the case. At pretty much every major publication in the world, there is a cybersecurity reporter or multiple cybersecurity reporters who have that particular beat. And it's because of the fact that cybersecurity is not just about esoteric applications anymore, it's about our daily lives. But application security is a subset of cybersecurity that is not necessarily well understood. So when you're dealing with your Amazon login, when you're dealing with your airline login, or when you're dealing with getting information off of any website, those are applications that you need to defend in a very different way than you defend your computer. So when people think about protecting those applications against vulnerabilities, there are a set of activities that some people have become quite familiar with in terms of looking for defects in the way that the software was created that allow you to create some sort of catastrophic harm through that application. But there's a difference between looking for those types of defects and defending an application that has already been constructed very carefully from a security perspective and has been scrubbed of all of the standard defects that people would think of. And that's what I would call application defense. And I want to give you an example of what it looks like if you have invested millions of dollars in an application and protecting it from a security perspective, but you still have a concern around defending that application against attacks. So here is a real-life attack on a Fortune 100 retailer. First of all, this is what normal traffic looks like. You see the nice diurnal periodicity of daily traffic if you're serving customers in a specific geographic region. Basically what it's showing you is that customers tend to use your site less when they're asleep than when they're awake. And so this is the pattern that you would expect to see if you had only organic traffic. This is not the pattern that this Fortune 100 retailer was seeing. They were seeing something that looked like this instead. And so what we did was we went into their environment and were able to show them for the first time the difference between the organic traffic that was coming from their real users and the attack traffic. And it was pretty eye-opening for them to be able to see that, in fact, 92% of all of the login traffic that was coming into their application was coming from attacks. Now, this is one of the world's largest, most sophisticated companies that had experienced security incidents in the past and was investing heavily in security controls already. They didn't have any obvious defects in their application, and they were not the type of organization that someone would say is not taking security seriously. And yet, how is it that the vast majority of the login activity that was occurring on their application was coming from attacks that were just sailing past those security controls? Well, it's because this is a different type of vulnerability than the vulnerabilities that we generally discuss. So what is going on? Some of you might be familiar with the OWASP Top 10. So the Open Web Application Security Project is a nonprofit that provides education and guidance on how to protect your applications against security defects. So the OWASP Top 10 is something that you should all look at if you haven't looked at it already in terms of thinking about how to be able to secure your applications from a traditional security perspective. But if you do all of these things and you invest very heavily in creating a secure application, that doesn't necessarily mean that your application is safe. OWASP themselves introduced a new handbook just last year that discussed all of the different types of threats that are particularly enabled through automation that are still present even when the OWASP Top 10 is dealt with. And that, in fact, is what we're looking at in that Fortune 100 retailer example. Let me tell you about exactly what was occurring there. And it has to do with passwords specifically. So Jeff Bezos provided some great guidance a number of years ago for the industry, and was one of many voices saying that we need to approach security more seriously, and at a very fundamental level, we need to learn how to create better passwords. Now, that message was pretty successful in terms of there being widespread recognition of what's a good password and what's a bad password. It didn't necessarily sink in to every single circle as far as educating folks on how to be able to create truly secure passwords. But in this example of Mark Zuckerberg using a really simplistic password, let's say that he hadn't used this as his password. Let's say that he'd used something that was much stronger. Say something like this, something that is definitely hard to guess, but also hard to remember and hard to type, but certainly strong from an objective standpoint. Would that have protected him against having his Twitter account taken over? And the answer is not necessarily. Because the way that Mark Zuckerberg's account was taken over was not from an attacker simply guessing his password, but knowing that he had used that as a valid password on another service, and in this case it was on LinkedIn. As a result of a data breach on LinkedIn, the attackers were able to immediately identify his email address being used and hypothesize maybe he's using the same password on Twitter, and sure enough, he was. LinkedIn's data breach that was reported in 2016 made it only the 6th largest data breach that was reported that year. We actually published a report earlier this year that tallied up the total number of passwords which were reported stolen, and it was more than 3.3 billion. And those are just the ones we know about, of course, and the ones that were reported. So how are these stolen passwords used? Well, the best example of this was actually provided a number of years ago by Sony. Now, Sony's unfortunately one of those organizations that has been attacked so many times, we have to talk about which particular security incident we're discussing here. And this was the one in 2011 where Sony actually did a great service for the industry in sharing what had happened in their environment. So what they explained was that attackers had obtained 15 million credentials from completely unrelated sites, and they used them to be able to log into the Sony PlayStation login. And because they'd used a botnet, it just looked like a popular day on their website. You didn't see a million login requests that were coming in trying to brute force a single account. There was just one login request per account, and it was distributed across many different IPs. And this is exactly the same pattern of behavior that you would see if you had a promotion that went out to a large portion of your user base. So Sony wasn't prepared for something like this. And so that allowed the attackers to be able to discover that there were 92,000 cases of credential reuse and accounts that they were able to take over. And the ecosystem has only gotten more sophisticated since then. This is the UI of Sentry MBA, which is the most popular credential stuffing tool in the world. This is a simulation tool that allows attackers to be able to make their million login requests look like they're coming from a million different users. You plug in the IP addresses that you've obtained from one source, the credentials that have been stolen by other cyber criminals, and then Sentry MBA orchestrates this attack so that it looks like it's a bunch of valid login requests. And it knows how to be able to change all of the behavioral characteristics associated with those logins to look like real humans as well. So what ends up happening is you've got a login form that you've created with good intention and hopefully with good security process and practices, and you've designed it so that the only way that you can authenticate to that application and get at all of the data behind it and the functionality behind it is if you have a valid password. So you think that you've created a very secure model, but now Sentry MBA actually has valid passwords that cyber criminals are able to use through it to be able to use that login mechanism against you and against your users. So what about CAPTCHA? So, CAPTCHA is the most widely deployed Turing test in the world. And a Turing test, of course, is the way that you would guard against simulated user activity. You want to be able to tell the difference between real human beings and a computer trying to pretend like it's a human being. The problem with CAPTCHA is that it just fundamentally doesn't work. So Google released some stats a couple of years ago saying that they did a study on whether or not state-of-the-art machine learning-based optical character recognition was effective in being able to solve CAPTCHA. And the idea behind CAPTCHA is that it should present a challenge that is easy for humans to solve and difficult for machines to be able to solve. And what Google discovered was that ML-based OCR now had a 99.8% solve rate, and real human beings had a 33% solve rate. Most of the time, we can't figure out what a CAPTCHA says. But if you present that as a challenge to a bot or to an attacker, they have built-in tools. This is actually the OCR that's built into Sentry MBA to be able to solve CAPTCHAs. And if that built-in OCR isn't sophisticated enough to be able to solve the CAPTCHA that's presented, there are also services like deathbycaptcha.com, which will solve 1,000 CAPTCHAs for you for $1.39. So all of this ties together to create what you might think of as the bad guy version of AWS. So the same way that we appreciate being able to use various services, being able to use different components that are built for us, and I love that quote from Jeff Bezos that Mackenzie mentioned about being able to get out of the business of undifferentiated heavy lifting. Well, cyber criminals have had those same challenges as well. Decades ago, when a cyber criminal would create a botnet, they would generally do that for their own use, which was at the time most commonly sending email spam. But today, if you've put together a botnet of millions of machines, you can resell that capacity to completely unrelated cyber criminals just to be able to bypass IP-based defenses for whatever purpose those other cyber criminals want. So you've got this commoditized, highly specialized, federated ecosystem that presents a much more complex challenge than any individual cybercriminal could ever present on their own. So the question is, how do you protect your services in light of this level of sophistication and complexity? So because of the work that I did at Google, I was brought in as an advisor for Facebook, Twitter, Pinterest, and a number of other firms as they were setting up their attack mitigation infrastructures for the first time. And this is the general framework that I created to be able to discuss all of the different areas that companies need to think about investing in order to create a comprehensive defense. And there are subcategories to these as well. One of the most powerful is thinking about your business model itself. What value do you offer that someone might try and obtain? What incentive do you provide for cyber criminals to attack you in the first place? If you can make changes to your business model, that's actually the most leveraged thing that you can do in terms of having impact to be able to protect yourself and protect your users. But that's not always, or even usually, a practical solution for most organizations. There's probably something magical about your business model that enables you to have an opportunity in the market in the first place. So then, in terms of technical defenses, there are various categories that you can think of, like reducing your attack surface. If there are 10 different ways to be able to access the data in your application, maybe it would be better if there were only 2 or 3 ways and you protected those 2 or 3 ways extremely well and redirected everyone to those 2 or 3 ways. An example of that is a login form. Many organizations just have a great deal of proliferation of login forms over time, and at some point they realize, you know what, we should have a group that's in charge of identity and access management for the application, create one login form, and protect that really carefully. But all of these areas are established fields and require a great deal of thought and investment, and at Google we spent hundreds of millions of dollars, as many large organizations do, to be able to invest in these areas and create a comprehensive defense. That is not really practical for smaller organizations, especially for startups. And one of the things that heartens me is the fact that organizations and services like AWS are changing that model. And so this might seem a little strange coming from someone in the security industry now, but I'm going to advocate that you don't buy security products. Instead, what I would suggest is you look for security services. So in the past, people would buy something like a web application firewall, and they would train internal resources to be able to operate that, and then they would have to keep up to date, and then they would have to go to the web application firewall user conference and make sure that they were completely up to speed on all of the updates that were coming in. That is a lot of time and effort, and it could be obsolete in a very short period of time for any given security or fraud technology. It's a lot easier to be able to just get the benefit of that security or fraud control as a service, and the fact that AWS's WAF, for example, is something that you can consume on a per transaction basis and not worry about all of the complexity associated with maintaining it, that's something that's very attractive. And there are other examples in other areas as well. So what I want to leave you with is that there is a happy ending to that story that I was relating to you before about the Fortune 100 retailers. So we revealed the organic traffic to them as well as the 92% of traffic that was attack traffic, but then we went into what we call blocking mode, and we prevented those transactions from reaching the origin server. And when you take the fight to the attacker and you invest in all of those different areas to be able to create an improvement in your security posture and in your overall ability to defend your application, the attackers respond as well. And in this case, what they did was, after trying to retool unsuccessfully, they just went away and attacked someone else. The adage in the security industry is that it's the story of being chased by the bear. That you don't have to be faster than the bear, you just have to be faster than your friend, who's also being chased. And so I think that when it comes to protecting your application, don't be the easiest target, because that's what cyber criminals are looking for. They're also running businesses. They're organized, they have an ROI that they're hoping to obtain, and if you're the easiest target, then they're going to concentrate their resources on you. So with that, thank you very much for your time, and feel free to email me if you have any questions.